السلام عليكم. احنا تيم 7 والريبورت بتاعنا رقم 55 السوبر كوندكتور، وده ان شاء الله هيكون الديجيتال اكتيفيتي بتاعنا. قسمنا الموضوع ل what is a superconductor, the discovery of superconductors, the history of superconductors, how do superconductors work, uses of superconductors, type 1 of superconductors and type 2, and future superconductors. The first idea, what is a superconductor? A superconductor is a material that achieves superconductivity, which is a state of matter that has no electrical resistance and doesn't allow magnetic field to penetrate. فكده احنا هنتعامل مع مادة من غير electrical resistance، يعني مفيش أي مقاومة كهربية هتكون موجودة في المادة دي. Who discovered the superconductors? The credit for the discovery of superconductivity goes to Dutch physics، عالم هولندي اسمه صعب شوية، في 1911 when he found that the electrical resistance in the mercury completely vanished. لما هو طبعا نزل درجة الحرارة لحد 4.2 كلفن، لقى إن الزئبق المقاومة الكهربية بتاعته اختفت. فطبعا لما عند 4.2 كلفن اللي هي بتساوي 7.56 فahrenheit. The history of superconductors. طبعا العلماء فضلوا عقود بيحاولوا إن هم يفهموا يعني طبيعة السوبركوندكتيفيتي، لحد ما في 1933 عالمين فيزياء discovered that the superconductor expel any nearby magnetic fields. وأخيرا في 1957 العالمان جون باردين، ليون إن كوبر and روبرت سكرايفر developed a complete microscopic theory of superconductivity to create electrical resistance. The electron in a metal need to be free to bounce around, but when the electrons inside a metal become incredibly cold, they can pair up, preventing them from bouncing around. These electron pairs, which called copper pairs, are very stable at low temperature, and with no electron free to bounce around, the electrical resistance disappears. How does a superconductor work? When a metal drops below a critical temperature, the electrons in the metal form bonds called copper pairs locked up like this. The electron can't provide any electrical resistance, and electricity can flow through the metal perfectly. However, this only works at low temperature. When the metal gets too warm, the electrons have enough energy to break the bonds of the copper pairs and go back to offering resistance. That's why in his original experiments found that mercury behaved as a superconductor at 4.19 Kelvin, but not 4.2. Uses of superconductors. The machine used powerful electromagnetics, which would melt normal metals due to the heat of even a little bit of resistance. وطبعا ده عشان كده السوبركوندكتور دول هما have no electrical resistance، عشان كده no heat is generated. فطبعا ده مش بيحصل melting للميتالز الموجودة، عشان كده السوبركوندكتورز بيستخدموها في الجزء ده. Similar superconducting electromagnets are also used in maglev trains, experimental nuclear fusion reactor, and high energy practical accelerator laboratories. One of the most interesting applications of superconductor is quantum computers. Anytime you need a really strong magnetic field or electric current and don't want your equipment to melt, the moment you turn it on, you need a superconductor. Type 1 of superconductors. There are two types of superconductors, and this is type 1. They call low temperature superconductors. They have low critical temperature from 0 to 10 Kelvin. كمان عندهم critical magnetic field and low critical magnetic field من 49 في 10 أس سالب 7 لحد 1 تسلا. Perfectly obey the Manager effect. Easily lose the superconducting state by low intensity magnetic field. Therefore, they are known as soft superconductors. The transition from a superconducting state to a normal state due to the external magnetic fields is Jordan. They cannot be used for manufacturing electromagnetics, used for producing strong magnetic fields due to low critical magnetic field. Type 1 superconductors are generally pure metals and they are completely diamagnetics, called soft superconductors. Examples like Hg, Pp and Zn. النوع التاني من السوبركوندكتورز high temperature superconductors. دي طبعا high critical temperature range from 1 to 10 Kelvin. طبعا برضو ليه high critical magnetic field greater than 1 Tesla. Partly obey the Manager effect. They can penetrate inside the material. Doesn't easily lose the superconducting state by external magnetic field. The transition from a superconducting state to a normal state due to the external magnetic field is gradually but not cheap. And this is the chart for that. They can be used for manufacturing electromagnets, used for producing strong magnetic fields, but they have high critical magnetic field. Type 2 superconductors are generally alloys and complex oxides of ceramics, completely diamagnetics. These are also called as hard superconductors. Example NPTI, NP, NB3SN and etc. مستقبل بقى السوبر كوندكتور دول. The holy grail of superconductor research is to find. هم طبعا عايزين يلاقوا material to act as a superconductor في الروم temperature العادية، ولحد دلوقتي أكتر حاجة لقوها وصلت إن هي 15 سيليزيوس، بس طبعا بتحتاج ضغط كبير جدا زي 267 جيجا باسكال، وده طبعا ما ينفعش. ده طبعا impractical. Room temperature superconductor would allow for the electrical transmission of energy with no losses or waste, more efficient maglev trains. A practical application of room temperature superconductor are limitless. Physics just need to figure out how superconductor work at room temperature and what the good looks material to allow for superconductivity might be.
A maglev train hovers above its track. A doctor uses an MRI scanner to detect disease. Fast digital circuits send superfast, clear signals from one source to another. These technologies are possible thanks to superconductors. Superconductors are materials where electrons can move without any resistance. But today's superconductors don't work unless they are cooled to well below room temperature. Now, researchers are using quantum physics on a quest to find superconductors that will work at room temperature to make them easier to use. There's been a problem in physics that researchers are trying to solve for years. Can we find something that can superconduct at room temperature? If we find it, it will revolutionize how we transport and use energy. When you cool lead, mercury, and certain compounds to extremely cold temperatures, they become superconductors. They stop showing any electrical resistance and they expel their magnetic fields, which makes them ideal for conducting electricity. But you need to use liquid helium if you're trying to get down to absolute zero, or minus 459 degrees Fahrenheit. That's why physicists want to find a high-temperature superconductor that will work at room temperature. It's just downright easier to work with. Researchers discovered superconductivity in 1911. By the 60s, they thought they had solved all of its mysteries. But in 1986, two scientists in Zurich discovered superconductors that work at higher temperatures than researchers thought were ever possible. These materials work as high-temperature superconductors up to minus 225 degrees Fahrenheit. Now that we have materials that can superconduct above the boiling point of nitrogen, we can finally use them in certain applications. Neither MRI machines or the particle accelerator at CERN would have been possible without the use of liquid helium-cooled superconducting electromagnets. Researchers still do not understand how to predict which material will be a high-temperature superconductor, or what causes their superconductivity. Green is studying copper oxide and iron-based superconductors for clues on why the electrons inside them act in such an unconventional way. Solving the problems that come with higher temperature superconductors, Green believes researchers will discover a room temperature superconductor in the next 30 years. If that happens, it could solve one of the greatest mysteries of physics at the tiniest level.
And thank you for listening.